Terms with the exact same variables raised to the exact same corresponding powers are called like terms. Please note that the variables do not have to be in the same order. Let's determine whether or not each set of terms are like. 2x and 3x. We ask ourselves, do we have the exact same variables raised to the exact same power? The first term, x to the first. The second term has x to the first. So yes, indeed, these are like terms. In our next example, 4a squared b to the third c to the fourth and 11b to the third c to the fourth a to the second, we want to see, do we have like terms? In the first term, I have a to the second. Do we have that same variable raised to the same power in the second term? A to the second, yes. Then we look and we see b to the third. Do we have b to the third in the second term? Yes, we do. Lastly, c to the fourth in the first one, c to the fourth in the second one. These are like terms. It's most common that we will have different numerical coefficients on our terms, whether they're like or not. Our last example, 6mn squared and 8nm squared. I'll go through the same way. The first term has m raised to the first power. Does the second term have m raised to the first power? No, it doesn't. It has m raised to the second power. So these are not like terms. Like terms can be combined by applying the distributive property. Recall the distributive property of multiplication over division. A times the quantity b plus c is equal to a times b plus a times c. It is possible that the multiplier is at the back, and we just distribute it in the same way as we did the first. Consider 2x plus 6x. Using the distributive property of multiplication backwards, this can be rewritten as 2 plus 6 times x. Following our order of operations, we'll add what's in the parentheses first, which gives me 8, and then the x is still there. So 2x plus 6x gives us 8x. An algebraic expression is simplified when all like terms have been combined. Let's simplify each expression by combining like terms. The first thing you want to do is identify whether or not you have like terms. 8m minus 14m. Those are like terms. Each have the variable m raised to the first power. So now all we need to do is add or subtract the coefficients. 8 minus 14 gives us negative 6m. In our next example, we see that not all terms are like. We have variable terms that are like, and then we have constant terms that are like. Let's combine the variable terms first. 6z plus 1z gives me 7z, and positive 5 minus 4 is a positive 1. This algebraic expression simplifies to 7z plus 1. Let's practice using the distributive property. We're going to multiply 3 times 7a. And since this is a positive 3, when I rewrite, I'm going to write plus 3 times negative 5. Now we multiply. 3 times 7a is 21a. A positive 3 times a negative 5 minus 15. In the next example, we're distributing a negative number, so be careful with your signs. Negative 6 times 5. And then since we're distributing a negative 6, I'm going to write minus 6 here times a negative y. Negative 6 times 5 is negative 30. And a negative 6 times a negative y gives me a positive 6y. Next, we're going to simplify expressions by first applying the distributive property and then combining any like terms that we might have after we've distributed. I start by distributing my 5. 5 times 2y plus 5 times a negative 3, and then I'm just going to bring that minus 8 down. 5 times 2y gives me 10y. A positive 5 times a negative 3 minus 15, and then we bring down that minus 8. Now we want to look and see, do we have any like terms that we could combine? Yes, we do. We have constant terms that can be combined. Bring down the 10y. Negative 15 minus 8 more gives me minus 23. In our next example, we start by distributing the 3 only to the first parenthesis. So that's 3 times 2x, and then a positive 3 times a positive 1. This next part can sometimes be tricky because we don't see a number in front of the second parenthesis. Now, when a number isn't shown, there is an invisible 1 there. So we're going to be distributing a negative 1. It would be negative 1 times 5x, and then a negative 1 times a negative 1. Now we can multiply these 4 groupings. 3 times 2x, 6x. A positive 3 times 1 is 3. Negative 1 times 5x minus 5x. And negative 1 times negative 1 gives me a positive 1. At this point, we want to look to see if we have any like terms and then combine those like terms. We actually have 2 sets of like terms. We have these variable terms containing x's, and then we have constant terms as well that can be combined. 6x minus 5x leaves me with 1x. You can either write the 1 in front of the x or not. A positive 3 plus 1, positive 4. So we can either write our answer as 1x plus 4 or simply x plus 4. It's understood that there's a positive 1 when we don't have a number in front of our variable.